Hi everyone, let's learn about inductive transducer and how it works. Let's start with what is inductance. Inductance is actually an induced voltage in a circuit. The voltage is induced due to the variation of current in the circuit itself or due to the variation of current in the neighboring circuit. This is based on Faraday's law that mentioned the induced voltage is equal to the rate of magnetic flux in the circuit changes. The Faraday law can be explained using this figure. In figure A, we have a conductor that has been formed into a loop or coil. When we supply a current through the conductor, it will produce a magnetic field that encircles the loop. In figure B, we can see that the magnetic field expands due to the increases in current. As the magnetic field expands, it will cut all the other loops. Therefore, the current increases will affect all other magnetic loops. This field cutting has the effect of increasing the opposition to a current change, which what we call as reluctance. Reluctance is a measure of how the circuit opposes the flow of magnetic flux. Reluctance is used to calculate inductance, where the equation for reluctance is L equal to N square reluctance, where N is number of loops. Reluctance can be calculated using this equation, where it's depend on length L, mu, and mu naught multiplied with A. A is the area of cross-section, mu is core permeability, and mu naught is free space permeability. A variable reluctance sensor was designed based on the concept of inductance and reluctance. This sensor is also known as a variable inductance sensor. The basic concept of this sensor is that the change in the inductance value is depend on the movement of the core. Different position of the core will produce different value of reluctance and eventually produce different inductance value. This sensor is commonly used as a displacement sensor. The example of variable reluctance sensor is an eddy current displacement sensor as shown in this figure. Here is the probe of the sensor that contains a coil and also an alternating current power source. The alternating current flow through the coil and it will generate a magnetic field around the coil. When the coil is placed close to an electrically conductive material, which is the gray plate here, the eddy current will be induced in the material, which is the red magnetic field here. That is the eddy current magnetic field. If the flaw in the conductive material disturbs the eddy current circulation, the magnetic coupling between the material and the probe is changed and a defect signal can be read by measuring the coil impedance variation. This example will illustrate the concept of variable inductance sensor as a displacement sensor. The inductance value will change depending on the displacement or gap between the probe, sensor, and the measured object. These are all the information needed to calculate the inductance value. Here we can consider the core as the probe sensor and the armature here as the measured object. In the probe sensor, we can see that it contains a number of coils with alternating power supply. When the current flow, it will create magnetic field and induce eddy current magnetic field in measured object. The central flux path here is actually a pathway of magnetic field to create a closed circuit. It is like a magnet that creates closed circuit magnetic field from north to south. So the solution for this problem can be solved by calculating the reluctance for the system. And from there, we can get the inductance value. However, reluctance value is different in different objects. Here, for example, in this system, we have three components that contribute to the total reluctance. The components are core, armature, and gap. Using the reluctance equation, we'll be able to calculate the reluctance for each component. The first one is reluctance for core. To calculate the reluctance of core, we need to determine the length of the flux flow in the core and also the area of the flux flow in the core. While mu and mu naught is depend on the material used as the core. So the length for core is equal to the half of the circle that made the core. So it is pi r. And the area is pi r square. So from there, using the information that has given to us, we will be able to calculate the reluctance for the core. After calculating the equation, we will get the value of reluctance in the core is 6.37 mega per Henry. Next is to calculate the reluctance in armature. Again, we need to determine the length of the flux flow in the armature and also the area. So the length is equal to the diameter of the circle and the area we take the shape of 2RT. Why 2RT? 2R is the diameter of the flux flow, while T is the thickness of the armature plate. Again, mu A and mu naught is depend on the material used as the armature. After calculating, we will get the value of reluctance in armature is 6.37 mega per Henry. Lastly is to calculate the reluctance of the gap. Reluctance of the gap will depend on the length, which is the gap itself. However, since we have two sides of gap, we have to multiply it with 2. And then for area, it will take the same shape as the core area. Therefore, it is pi r square. As a mu A is given to equal to 1. So therefore, we have 1 here. And mu naught is the constant. Since this sensor is designed as a displacement sensor, meaning the reluctance will be different if the distance is different. So therefore here, we will calculate for two types of distance, which is d equal to 0, and the second one is d equal to 1 mm. So when the gap is 0, the total reluctance will be equivalent to 12.73 mega per Henry because the reluctance of the gap will equal to 0. So from there, from the total reluctance value, we will be able to calculate the inductance value, which is n to the power of 2, divided by reluctance. So the number of coin is 500 square divided by 12.73 mega per Henry will give us the inductance value is 9.6 millihenry. And if the distance is 1 mm, meaning we will replace d here with 1 mm. So after calculating it, we get the reluctance value of gap is this value here. Then we put into the total reluctance value, which gives us 3.3 to the power of 7 per Henry. And the inductance value will give you 6.7 millihenry. So therefore, when the distance increase, we will see that the inductance value will decrease.